Okay, so in week 8, last lecture Tuesday, we learned a scatter plot, 3D scatter plot, we learned pie charts, and also we learned about box plot, okay? Today, we're gonna continue on box plot and how we can add like more box plot inside one graph. And beside this box plot, we're gonna also learn violin plot, which is similar to box plot, okay? Let's go and learn how we need to code to create multiple box plot inside one graph, okay? Week 2, week 8. Week 8. Section 2, and we are starting with the learning box plot, okay? I'm gonna create my set of data for box plot. If you remember, we said we only need one set of data to put and pass it inside the function and create that box plot, which box plot comes up and give information about that data set, that how many and median, maximum, minimum, and how many like lower than this part we have, how many like upper than this value we have, that kind of information. It just give return to us, okay? So first we're gonna import our library, import matplotlib, okay? Matplotlib dot pyplot module as PLT to make it short, okay? Here I'm making my first set of data, which you can put whatever you want, just some random numbers, okay? 3, 4, 6, 8, 9, 5, 6, 7, 2, 1, 0, and nothing else. 3. And I'm creating another data set, so we want to have multiple box plot, okay? Let's create another one, call it B, and just add some random number into it, but remember to do not put too much like different. I mean, like here you see in A, I put all numbers between 0 to 10, okay? If something big like 100 I added to it, it goes as outliers, okay? It shows as outliers because it's out of the normal range of data that we have, okay? Let's try to put numbers close to each other. However, you can absolutely add it, but it's gonna count it as outlier and show that point as outlier to you. Let's put some values for B. I put 4, 8, 9, 11, 10, 15, 13, 14, what else? 12, again 15, 12, 7, and on like 19. I'm gonna create another one, call it C, and put some random number into this one too, like 9, 5, 7, 10, 20, 13, 15, 16, something like that. For box plots, we use function box plot, okay? Let's call the function that we need to create this box plot. Okay, here from PLT, I call box plot function. Now, inside this function, let's pass our data. So you remember, previous time, I mean last lecture, we learned, okay, I want to pass this A to it, and just I put A, pass A here, and then create my my function here, okay? Like this. See, I just run it. I just run my program, and now it created like that. And we said this orange line is median, the median value that it has inside the set of data that we have, okay? Is also, we have another argument, which is mean. I mean, when you want to display mean, the average value of whole your data set, it can display it by passing the argument show means. Okay, show means. So here we can say that pass the argument, call it show means. Show means equal to false, it doesn't show it. Show mean true, it show it. Now, so let's create that title and everything that we learned in line plot. It is all similar, okay? For title, I just write title and call it inside the quotation mark, I call it box plot. That's it. There is another function, it call it grid. Grid makes that lines, okay, inside your graph. So here is blank. See, inside my graph, actually there is nothing. It's blank. If we put and call the function grid, it added some line and features to your figure. For the grid function, pass true argument into it, okay, to display that lines for you. And to write, I told you before also, to write off all this data about your box, just write this line of the code, show, okay? Just write this show function, okay? Show function. What else? Okay, now, as you see, I have only one box plot passed to my graph. So if I want to pass more data set, I just put it here, but not like this, not like A, B, C. It would not accept something like this. It should be inside a set. It should be inside a set, okay? Therefore, we go and use that braces to put all data set inside. Use this braces, okay? Now run it. See how nicely we have this grid feature inside my, in the background of my plot, and also by number. So the first one is A, that passes to our function. 2 is the second one, B, and 3 is C, okay? See how nice. And this green dot that displayed here is our means, the average value, okay? Sometimes, I mean, most of the time, the average value is close to median. Median is the middle value that we have, okay, inside the data set. And see that this green dot is somewhere close to that part, okay? This is all about box plot. We learned box plot is mostly commonly for that when we want to get some information about our data set. For example, age, okay? We have a range of age, okay, of participants. I put all them inside the box plot to see, okay, 25% like of my participant is between like this 4 to 9 for this one. See, we can understand that kind of things from this box plot. So the next one is violin plot. Violin plot is same thing as a box plot, okay? Mostly it comes and make a shape around it, which is the probability density function, okay? It shows probability density function. Where the data or that values is more, where it's less, okay? Where we have more values, it show it like that, which call it probability density function. I have this old data set. The only things that I gonna do here is this box plot. Here I had this function, okay? Okay, to do not delete it. I don't want to delete this part. You also don't delete it. Just let's copy paste it, okay? Let's copy paste this part. I'm gonna copy here and paste it down here, see? And this one is what? This one is Violin Plot, okay? So here instead box plot, I'm gonna just call violin plot function. Just write violin plot function, that's it. Okay. Again, this notebook. I stop typing and writing. Okay. Violin plot. Violin plot, and here I have this violin plot. That's it. Okay. We pass ABC and grade is true, and let's run it. See, it show us a nice probability density. In the first one, in number one, it tells us it's almost more values around 5, okay, here. So for 3, if you look at it, it's a more density of values is in the down part, in 50% down, okay? Because you see here we have a bigger, a kind of like fat, and the upper part got like narrow. So that show us that we have more values in 15% down, okay? Here in the second one, it shows actually we have more value around 12, okay? Around 12, we have more value. So the second one was B, around 12, you say around 12, we have more value that going around this data, but like around 4 or 19, we have less number here, around 4 and like 19 that we have, less numbers, less values going on over there. See, that was all about violin. And this one, this line at the middle is mean, okay, as we mentioned here, show means, okay. The bottom line is minimum value that we have in data set, and the upper line is maximum value. This was all about box and violin, and the other features we learned in line plot, we can add it here, like axis, colors, and that kind of things, okay? The next one that we gonna learn is histogram, okay? Histogram is actually all about count, okay? The data that we have, we put that data in like axis, okay, x-axis. The x-axis is the value that we have, and the y-axis is frequency, okay? Is frequency distribution. It just counts how many of that value or item or what we have there. It just counts. It is frequency distribution of the data that we have, okay? Let's create one histogram also. We have some data. Let's create a data set, call it data, and put just some random values into it, like 1, 3, 3, 5, 5, 5, 6, 8. They're so close to each other. Why I put so close to each other? Okay, 3 was good. Okay, I'm gonna put 6, 6, 6, and then 9, 9, 9, 9, 9. Because it's gonna count how many value, how many item of that kind of things we have, okay? Because of that, I put this kind of random numbers. If you put one number of any like values, so it's gonna just show 1 for all of them, okay? Because of this, I put a different count of number for each value that I have here. So the next one, 11, I put 11 to 11 I have, then I'm gonna add also 4, 4, 4, and that's it. Yep. Here, let's go and call our histogram function, okay? From PLT, I call dot hist. That's my histogram, hist function, okay? Histogram. What we pass to this function, the first thing is our argument, data, okay? Then let's pass data to it. And the second one, which is important, is beans. What does beans do? Actually, beans is the range of our x-axis, okay? The range of this x-axis, that how close they are or how like wide they should be, that kind of things, okay? The range of values in x-axis, how wide they should be. So if I put 10, let's go and display this plt.show. Let's go and display this. Okay, see how nicely actually here we got our histogram. I'm gonna increase beans. Let's see what will happen. First, I decrease it. I put it 5 into it. I think 5 is so low. See, it actually make it 5 is the whole range of data that I have here. Therefore, it put close to each other that bars inside this histogram graph, okay? So if I increase it like to 20, see what is the difference? Now it put that space more, okay? So look at this graph. This one is number 1 here that we have in data, okay? It say we have only 1 of 1 value. For 3 also we have 1. This is 4, we have 3. See this frequency, y-axis is frequency part, okay? Let me write it here that I'm adding that labels for x and y, okay? First, I'm gonna give a title to my graph and call it histogram. And then I'm gonna make that x label, okay? X label is actually range of values that we have, range of values, okay? And plt.y label, okay, let's put this y label, and this is frequency, okay? This is frequency. And what else? Okay, now we learned it that how frequency, for frequency, we just pass one data set and we want to check the counts, the frequency of that values. That's it, okay? What else we can pass to this? Okay, the color, we can play around with that colors, okay? We have this edge color and color around this one. We can add that grid that we learned, plt.grid, and pass true argument into it. And that's it. So for color, inside histogram function, let's add some color, give some features to our histogram graph. Okay, I'm gonna say color, but the color can be, the color can be green. J consider as green, and we have something called edge color. Edge color can be this green, edge color can be red. Okay, do you see it here? So I have edge color which is red, as we said here, and the itself is green. We have also that grid lines in our background, part of histogram graph. And this was all about histogram. So histogram count the number of values that we have. Histogram is actually that frequency. That's it, okay? This is all about the histogram part that we have. Let's go and learn some area charts. Yes. First, we're gonna go and learn this area chart that I showed to you at the beginning of this visualization part, okay? This was histogram. I'm gonna comment out this one and call it histogram plot, okay? Here, let's go and create our area chart, okay? Let's go and create an area chart. What is area chart? Area chart actually, do you remember that line plot that we learned? We were using that plot function, only plot function, and passing some variable, and it was creating a line for us. It was attaching that points to each other and create a line. Area chart is the same thing, okay? We have a line, first we create that line. We create that line plots, then it comes and make a shade under that line that make our area. Inside the math is same thing actually. See, that's the area. So all the shade under that line is our area. That's the point. That's a point of area chart. Okay, let's create some area chart. Okay, I'm supposed to create a point to create that line plot. Therefore, I need X and Y axis, okay? Let's create our X and Y axis here. Let's put some number. For X, I'm gonna put 2, 3, 4, 5, 6, 7, 8, 9. That's okay. For Y, I'm gonna put 4, 6, 3, 7, 8, 9, and then 7. And what else? And then 7. And remember, in line plot, the number of values inside X and Y should be same, okay? Now let's go and create. So for creating that shade under our line, we call a function which is called a stack plot, okay? It called it a stack plot. Let's call that function from this PLT. PLT dot a stack plot, okay? A stack plot. Oh, a stack plot. Okay. Inside a stack plot function, what kind of argument we pass? We pass our X and Y. We give that line to it, okay? It recognizes the line and automatically creates a shade under it, okay? X, Y. So I pass my X and Y, okay? The other things is your shade. You want to have a color your shade. Therefore, you can put some colors for it, okay? We pass the argument colors. Colors equal whatever you want, like you want red, blue, whatever you want, okay? Now let's create our line. So we want to display our line at the top also, okay? PLT dot plot. Plot was a function to create that line. We pass our X and Y here also. And let's put some color to our line. I want to make it black. K, consider as black color here, okay? Now let's put that grade function that we learned. We just learned it. PLT dot grade and passing argument true into it, and then let's write that line of the code show my function, okay? My function. And now let's run it. See how nicely we have a red area, the shaded area under the line that we have the X and Y line. What kind of other argument we can pass in that stack plot? Actually, it is a lot. So one of them is alpha. Alpha, what alpha does actually, this alpha make it lighter or transparent, make it transparent, okay, and lighter and that kind of things. The shade color under this line. Let's see, alpha equal on default alpha in 0, so from 0 to 1 we can change it like 0.5. Let's see how it can change. Oh, see how it changed. It made it like more lighter, okay? The red color got more lighter. Let's see if I put like 8, what will happen? 0.8, alpha 0.8, okay? It make it like, yeah, darker. 3, make it more lighter, see? Okay, what if I want to pass more, like not just one area, I want to have more area, okay, inside this graph. So how are we gonna do it? Do you remember how we were creating and adding more light into one plot? We're gonna do same thing here, okay? We're gonna add our data with calling more plot function and a stack plot function, okay? Let's go and do same thing. I'm gonna add one more data set. I call it like XYZ, okay? I call it Z, and let's add some random number into it. I want like 2, 4, 6, 8, and what? 9, 10, and now coming down like 2, 8. And the number of our value should be same, 1, 2, 3, 4, 5, 6, 7, 8. 7, 8, okay. This is 8. See, this was the first one, okay? I want to add another one. Therefore, I'm calling another function of this stack plot and plot, okay? Let's go and call for my second plot dot my second area chart, plot dot stack plot, and let's passing, I want to pass X and Z, okay? X and Z. Let's put a different color for this one. Colors. Okay, the previous one is red. I want to make this one blue. Okay, I want to make it blue to be different, or green or something. Do we need to use alpha? I don't know. For now, I don't put alpha there. So now let's create an XZ line. PLT dot plot, and passing the arguments and values of X and Z. Let's put a color for our line. I'm gonna make it color like black. Let's this one also be black. Okay, mean black. And now let's run it. See. The second, actually the second area that we create came in top of the previous one, okay? We're gonna fix it. So I'm gonna put alpha for this one, or probably we need to put codes in the different lines, or let me see if this alpha can help us to make them transparent and just show both of them. For alpha, I'm gonna put this one 0.3 and just delete alpha for the first one, okay? Let's see how this one can help us. This one, I kinda help it. The blue one, this one, as I said, it got transparent, okay? And it is visible. This one is a kind of visible. So it's gonna come something like that. Let me see if I put codes like in different place, it can also help or not, okay? Or how about if I just delete this alpha from here also? No, that alpha was good there. Alpha equals 0.1. This is kind of better. Actually was good. How about if I cut this one from here? I don't know if it's gonna have any impact on our graph or not, but let's see. Let's see. Kernel restart. Since I restarted, I have to come from here because I need this line of code. I can just copy this one. No, it's same actually. When I changed the place, it was same, but the way that we can change the color and one of them be transparent and the other one be visible is with this alpha, okay? This alpha can help a lot. And what else? This was about area. We can add even more lines and that area to it, and kind of that's everything about area chart, okay? We have another things to talk today. Okay. We learned about this line plot and also putting that plot. We have something that we can all the time use it. Sometimes you have, like, do you remember we try to add lines inside one graph, or area inside one graph, or everything inside one graph? Sometimes, okay, I want to display them next to each other in separate graphs, not on top of each other inside one graph. Okay, I want to have them next to each other, like in different position, just display them at the same time together. How we can do that? There is a function called subplot. Anytime that we use that subplot, we can tell what plot, what graph go where, like in the left side, in the right side, in upper, in down, or how many they should be. That kind of things we can use, okay, with this subplot. Let's go and learn how to use this subplot, okay. Here I have this XYZ, okay, I'm gonna use this line, XYZ, okay. I would not create any other variable. So this XYZ that we have here, I'm gonna use them, and here I just gonna call the function subplot, okay? PLT dot subplot, okay? Dot subplot. What we pass inside this subplot. This subplot gonna be only for one line, okay? For one graph. Inside this subplot, the first thing that we pass is the number of rows. What means the number of rows? Okay, the number of rows, that how many graphs we want to have. Okay, one graph here, the other graph here, the other graph here. And this is 3 rows of graph that I want to display, okay? So the number of rows, the first graph, second, and third, like that, okay? So here, how many like rows I want to have, or how I want to display my graph. So I want to display my graph next to each other in columns, okay? Not in rows under each other. I want to display them next to each other as a column. 1 column, 2 column, 3rd column, okay? Therefore, I have 1 row. I want to have 1 row and how many, like 2 columns, okay? 2 graphs next to each other. And where subplot is for the first one. Now for the first line plot that we want to create. Okay, where this one goes in like indexing. So it's gonna come in the first one. I just put 1 for this one. In the first place, I want to see this one. Okay. Now let's go and create our line plot by using that plot function. PLT dot plot and passing x, y. Okay, I'm passing this x, y into it. And I'm gonna put a title to do not get confusion. PLT dot title. This title is like graph 1. Okay, graph 1. Okay, let's run this one. See, this is my first graph. Just displayed it like this. Now let's go and create our second graph that we want to display it exactly here next to it. Okay, I'm gonna repeat everything again. PLT dot subplot. This subplot actually should be a kind of take out the data from here, okay? So how many row, how many column, it didn't change. But still I have same rows and column. I mentioned that 1 row and 2 columns I want to have, 2 columns of graph. So here I can say 1 row and 2 column, and where this line plot, the next line plot or graph 2 gonna sit in the second place, okay? And let's create our plot, line plot, PLT dot plot x, z. I'm passing x and z. Now PLT dot title, okay? The title gonna be like graph 2, graph 2. Let's run this one. See how nicely it came and displayed them next to each other, okay? Now if I want to add like 1 more graph to all that, PLT dot subplot. I keep continuing, okay? Subplot. Okay, I want to say 1 row and 3 column, okay? I want to add 1 more column, 1 more graph into it, okay? Then I put 3 as a column, number of columns here, okay? 3, and this one supposed to be 1 row, 3 columns, and in which place this one gonna sit in the third column, okay? plt.plot. This time I'm gonna pass y and z data into it, and also put a title for this one. Call it title. Okay. Title what? Graph 3. That's it. Okay. See how nicely I have my all 3 graph next to each other, displaying next to each other. And the other like features that we learned in line plot, we can use here for color, for that like range of like x-axis, y-axis, and that kind of things. And we learned almost everything in Matplotlib library. Yes, we are learned everything, and congratulations, we finished whole our Python course, the learning part. So you learn the Python from the beginning, how to code and all the syntax. In Python, you learn 3 important and useful libraries of Python for data analysis, which is NumPy, Pandas, and Matplotlib. We have 3 weeks more that we're gonna do project on them together, okay? Okay, so do you have any question? If you have any question, please ask me. But this lecture was the end of all learning part of our course.